Welcome back. Today I will discuss group theory. At first, just recall our previous video. In my previous video, I have defined the structure of the group A5, which is actually the subgroup of permutation group S5. And in my previous video, I have seen product of 3 cycle in Sn are always subgroup of An. That means all 3 cycle generate An. And third, if A is a subgroup of Sn, which is permutation group, then every member of A is an even permutation, or exactly half of members are always even. Okay? In my previous video, I have defined these 3 parts, and actually I have defined the group theory elaborately in my previous lecture. Yesterday, I have defined the group theory just as an exercise. Today's goal of this lecture is, today I will see, I have seen in my previous video, the cycle An always generated by 3 cycle, and today I will see An is a simple group when An greater than equal to 5. Today, since I will define this part, then at first I will define, just as a review, what is the normal subgroup. This part elaborately I have defined in my previous video, but today I will discuss the normal subgroup and some properties just as a review. The idea of normal subgroup. This idea has come from left coset. At first recall what is the left coset. We all of us know, if A is any element of the group G and A is B subgroup of the group G, then A is a subset of element in G, and we call this subset as a left coset of the group G. And if we multiply A from right side, then A is called right coset of the group G. Actually, for any group, left coset and right coset are equal. This is not necessary. And any group G is actually, this group is disjoint union of left coset. And when these left coset and right coset are equal, then this subgroup is called normal subgroup. We all of us know. That means actually the definition of normal subgroup is, a subgroup A is of a group G is called normal subgroup if A is equal to A is A. This is true for all A belongs to G. Then we denote A is a normal subgroup of G. This disjoint left coset actually partition whole group G. G equal to actually union of disjoint left coset first. Second, either this left coset equal or their intersection is phi, and cardinality of left coset and right coset always be equal. And when two left coset are equal, then this is called the normal subgroup. This does not always imply A is equal to A is A. From this idea, we can define another definition of normal subgroup. A subgroup A is of the group G is said to be normal if and only if A is A inverse equal to A, and this is true for all A in G. And this means actually conjugation by the element A. we all of us know the idea of conjugate subgroup. A inverse A. That means we have a conjugate for each A belongs to the group G. And if A inverse A is A equal to K, then we can tell A is and K both are conjugate subgroup. We will see some example of normal subgroup. In my previous video, I have defined elaborately some group, and in this group, which subgroup are normal and not normal. At first, I will hardly recommend you, if you don't see my previous video, at first see my previous video. Normal subgroup. Identity and group itself always normal subgroup. We all of us know. And when a group is abelian, then always every subgroup is normal subgroup. And why in abelian group, why every subgroup are not normal, this is I have defined in my previous video. Just see my playlist. So when the group is not abelian, then always every subgroup not be normal. As for example, consider G equal to S3. We all of us know in S3 only normal subgroup is A3 and other proper subgroup of S3 are not normal. As for example, just as a review, for example, if consider G equal to S3 equal to set containing the elements F1, F2, F3, F4, F5, F6, and consider A is equal to set containing the element F1, F2. Obviously, A is a subgroup of S3. Why check A is be a normal subgroup? Consider another permutation which is F3, and F3 is 1 goes to 3, 2 goes to 2 and 3 goes to 1. Obviously, F3 square is also identity permutation. That means F2 inverse equal to F2 and F3 inverse equal to F3. Now, to check is A is normal or not normal, F3, F2, F3 inverse. Obviously, F3 inverse is actually F3. Then this is F3, F2, F3. And how look like here the cycle? At first F3. In F3, 1 goes to 3. Then F2. In F2, 3 goes to 3. 3 goes to 3. Then F3. In F3, 3 goes to 1. Here F3, here F2 and here also F3. That means similarly 2 goes to 2, 2 goes to 1 and 1 goes to 3 and 3 goes to 1, 1 goes to 2 and 2 goes to 2. Therefore, F3, F2, F3 inverse, which is actually equal to F3, F2, F3, and this cycle is look like the cycle 1 and cycle 2, 3, because 1 goes to 1, 2 goes to 3 and 3 goes to 2. Therefore, F3, F2, F3 inverse does not belongs to the subgroup A. So, this subgroup A is be not a normal subgroup in S3. So, in S3 there exists only one proper subgroup. This is A3. Actually, this is not be a normal subgroup because look the definition of normal subgroup. A is A inverse equal to A is. This is true for all A belongs to Z. That means since A is A inverse equal to A is, this is the definition of normal subgroup, that means this is actually closed under conjugation. Here this is conjugation by the element A. Therefore, actually a normal subgroup is actually union of all conjugacy class. Hence, I have considered the subgroup A is equal to the set containing the elements F1, F2, where F1 is identity and F2 is 1,2 cycle. This is not normal subgroup of S3 because conjugacy class of S3 is, first no, in permutation group, conjugacy class means same cycle type. So, conjugacy class of S3, equal to 1 plus 1 plus 1, 3 equal to 2 plus 1 and 3 equal to 3. Therefore, the conjugacy class of S3 equal to identity and the cycle 1, 2, 1, 3, 2, 3 and the cycle 1, 2, 3 and 1, 3, 2. This is the conjugacy class of S3. So, the subgroup A is not be a normal subgroup because all conjugacy class of S3 does not contain in this subgroup. So, this subgroup not be a normal subgroup. This is subgroup of S3 but not be normal subgroup because normal means always contain union of all conjugacy class. Okay. So, only normal subgroup of S3 is A3 because this subgroup A3 contain all conjugacy class of 3 cycle in S3. So, A3 be normal subgroup in S3 and only normal subgroup in S3 are, we all of us know, identity, S3 own self and A3. Now I will say what is the normal subgroup of the permutation group S4. To find the normal subgroup of S4, at first we have to find how look like the cycle type of S4. We all of us know the cycle type of S4 are 1. Trivial cycle, another 2 cycle and 1 cycle, another 2 plus 2 cycle, 3 cycle and 4 cycle. The cycle type in S4. And we all of us know actually in a subgroup if all type of cycle contain in this subgroup, then this subgroup is obviously normal subgroup. How look like this normal subgroup of S4? At first I will see the subgroup of S4. When cycle type 1, then number of elements in S4 is 1. And then number of subgroup of order 1 is obviously 1, this is isomorphic to Z1. And when the cycles type is 2, 1, 1, then number of element of this cycle type is 9 in S4 and the elements would be such type. This cycle I can construct one subgroup in S4 which is look like the element EI 1, 2, the element E identity 1, 3, the element E 2, 3, this type of subgroup, this is. Since here the number of elements of this type of cycle is 9, so number of subgroup, we all of us know the formula 9 over phi 2 which is 9, and this type of cycle obviously isomorphic to Z2. And other cycle in S4 when the cycle type is 2 plus 2, then the subgroup is look like the set containing the elements identity 1, 2, 3, 4 or the subgroup look like identity 1324 or identity 1423. When the cycle type is 2 cross 2, then we can construct this type of subgroups. So this type of subgroup is not normal subgroup in S4, because if we consider this type of subgroup identity 1 2, identity 1 3, identity 2 4, 2 3, this type of subgroup does not contain all conjugacy class of 2 cycle, which is look like 2 1 1. Similarly, if we consider this type of subgroup identity 1 2 3 4, this does not contain all conjugacy class of 2 plus 2 cycle. When the cycle type is 3 plus 1, then the cycle would be such type. All 3 cycle in S4 would be such type. And number of elements of this cycle type is 8. So, subgroup who is constructed by this cycle, whose order is 3, is look like this type of subgroup obviously of order 3, and this type of subgroup obviously would be such type identity 1 2 3, and inverse of 1 2 3 is 1 3 2. Similarly, we can construct another subgroup of order 3. Number of subgroup of order 3 here 8 over 5 3, which is equal to 4. Order 3 subgroup not be normal subgroup because this subgroup does not contain all 3 cycle, all 3 conjugacy class. So this cycle not be normal subgroup. And in S4 there exist 2 subgroup of order 4, and the subgroup is look like identity 1 2 3 4, and inverse of 1 2 3 4 is 1 4 3 2 and 1 3 2 4. And this type of subgroup is actually isomorphic to Z mod 4Z. And another subgroup of order 4 is identity 1 2 3 4, 1 3 3 4, 1 3 2 4, 1 4 2 3. Obviously, all of us know this type of cycle is isomorphic to KN4 group. That means in S4 there exists 2 subgroup of order 4. One subgroup is isomorphic to Z mod 4Z, and another subgroup is isomorphic to KN4 group. This subgroup not normal subgroup in S4, Z4, not normal in S4, because this 3 cycle and 2 cycle does not contain all conjugacy class. The subgroup which is isomorphic to KN4 group, obviously this is normal in S4, because this is normal because notice here KN4 group contain all 2 plus 2 cycle. So in S4 KN4 group is a normal subgroup because this is contain all 2 plus 2 cycle. Okay, OL. This is normal because notice here KN4 group contain all 2 plus 2 cycle. So in S4 KN4 group is a normal subgroup because this is contain all 2 plus 2 cycle. Okay, OL. S4 the subgroup of order 6 would be isomorphic to S3. Also this is not normal because in S3 this does not contain all conjugacy class of 2 cycle and 3 cycle. Another subgroup of order 8 which is actually isomorphic to D4, and the construction of the subgroup would be such type. And another subgroup of S4 is A4. 4 means since even permutation, so this contain this type of cycle identity 1 2 3 4, 1 3 2 4, 1 4 2 3, because this is this all even transportation 1 2 3 132, 124, 143, 134, 143, 234, 243. And notice in A4 this contain all conjugacy class of cycle type 2 plus 2 and cycle type 3 plus 1. So obviously in S4, A4 is a normal subgroup. And S4 own self obviously normal subgroup. So in S4, identity, Killenford group and A4 is a normal subgroup. I hope my all viewers have understood this type of construction. I hope my all viewers have understood how look like the subgroup in S4 and how look like the normal subgroup in S4. How we have to find the normal subgroup in any permutation group. Okay? Well, my all viewers have understood how look like the subgroup in S4 and how look like the normal subgroup in S4. How we have to find the normal subgroup in any permutation group. Okay? Well, now I will see what is the normal subgroup of A4. We all of us know A4 constructed by this type of cycle. Now I will see what is the normal subgroup of A4. In A4, the elements are order 1 elements is only identity which is isomorphic to this subgroup is isomorphic to Z1. Order 2 element is 3 and number of subgroup of order 3 over phi 2 which is isomorphic to Z2 and this subgroup is such type Z2 is identity 1 2 3 4, identity 1 3 2 4, identity 1 4 3 2 3. This 3 subgroup in A4 is order 3 which are isomorphic to Z2. This subgroup also not normal subgroup because if we consider this subgroup, then this subgroup does not contain all 2 plus 2 cycle in this subgroup. Therefore, these 3 subgroup be not normal. Then there exist 8 element of order 3 and the subgroup of order 3 would be number of subgroup is 8 over phi 3 which is 4. There are 4 subgroup of order 3. Notice identity 1 2 3 1 3 2, identity 2 3 4 2 4 3, identity 3 4 1 3 1 4 and another subgroup is identity 4 1 2 4 2 1. These are 4 subgroup of order 3 in A4. Okay, and these 4 subgroup also not normal because if we consider this subgroup, notice this subgroup does not contain all 3 cycle in A4. Notice all 3 cycle of A4 is how look like. Another subgroup is 4 order subgroup and there exists no elements of 4 order and this subgroup is actually isomorphic to Killenford group because the subgroup here 4 order subgroup is look like this type and there exists one subgroup of 4 order which is isomorphic to Killenford group and obviously this subgroup is normal subgroup because this subgroup contain all 2 plus 2 cycles. So this is the normal subgroup in A4 and we all of us know in A4 there exists no element of order 6 and another subgroup is group itself and here the group itself is A4. Therefore, the normal subgroup in A4 are identity, Killenford group and group itself means A4. All of us know a group is simple if it has no proper non-trivial normal subgroup. Let's come back our next goal. I will say the group A5, the permutation group A5 is a simple group. And what is the simple group? We all of us know a group is simple means it has no proper non-trivial subgroup. A5, we all of us know in A5 there exist 24 elements of 5 cycle, 20 elements of 3 cycle, 15 elements of 2 cycle and 1 elements of 1 cycle. This is the structure of A5. But in subgroup structure there are no proper normal subgroup in A5. Only normal subgroup in A5 are identity and group itself means A5. So, since there are no proper normal subgroup, so the group A5 is simple group. Actually, AN is a simple group when n greater than equal to 5. Otherwise, this is not simple. Actually, in A5, other proper subgroup not be normal because this subgroup does not contain all conjugacy class of this subgroup. So, this subgroup actually contain more elements of conjugacy class or less element of conjugacy class. So, this subgroup not be normal. Okay? OL. Okay? OL. I hope my all viewers have understood this concept. This concept very easy concept but very conceptual. So I have defined this concept just as a review and more knowledge. Today I will stop here. See you soon. Stay safe and stay positive always. And don't forget to subscribe my channel for more videos. Thank you so much.